Welcome to the My Tech Toolbelt podcast. We're your hosts. I'm Shannon.
And I'm Brenda. And this is a podcast where we highlight educators who innovate, engage, and inspire through the use of technology. Welcome to the My Tech Toolbelt podcast, episode 22. Have you ever thought about exploring the world of 3D printing? Do you feel a little intimidated by them? Well, join us today as we talk to Bryan Adams, where he tells us all about the different types of printers, the price points, maintenance, and things to look for in a quality printer. He also gives us resources for templates so that you can get started right out of the box. So, without further ado, our interview with Bryan Adams.
This morning, we are really excited to welcome our in-studio guest, Bryan Adams.
Hello,
Yay,
hello.
Good morning.
Welcome,
Good morning,
Bryan.
good morning.
So Bryan is an AP computer science teacher at Bishop Montgomery High School in Torrance, California, and longtime friend. I don't even know how long we've known each other, but a while.
It's been a while. It's close to a decade now, probably.
Okay. Wow. That makes me feel old, so don't say that anymore. And Bryan's going to talk to us today about how he is using his 3D printer in his classroom. He brought some cool stuff that I've played with and built geometric figures here in the studio. So welcome, Bryan.
Thank you. Thank you for having me. Yeah.
We're very excited to have you here. We don't know much about, or at least I don't know much about 3D printers.
Sure. Yeah. Honestly, a couple of years ago, I didn't know much about 3D printing myself. I think it was ISTE in Philadelphia the first time around. It's coming back around to Philadelphia this year. I sat in on a session with Dr. Chris Kraft. He was doing a prosthetics challenge, a prosthetics print challenge. But the real gist that I took away from that was he was doing projects with 3D printers to have students design and create and refine and develop solutions that can go out into the community. If it was some sort of assistive device for senior citizens or the prosthetics that he was printing, I just thought that was such a neat idea that I work at a Catholic school, so I really wanted to bring that idea back and start having our students contribute back to the community. So Dr. Chris Kraft is really kind of where I got that passion from, and been printing ever since.
Bryan, will you tell us a little bit about your background as an educator and how you came about to the school that you're teaching at?
Sure, love to. So I was not formally trained as an educator. I don't know if I actually want to say that, but
That's not the first time we've heard that on the podcast, so it's okay.
I didn't set out in life to be a teacher, but about 10 years ago now, I was looking for a job, and I've always been into technology since I was a little kid. Probably started building computers when I was around 12. And I saw a position for technology instructor at Pacific Elementary, which is a great school in California. I blew away the competition with some of my testing and did a bunch of demo classes. They really liked the way I worked with the kids and been teaching ever since. I was actually pink slipped that first year. I then developed a presentation through my principal asked me to help develop an outline, a presentation of the work that I was doing with the kids at that time. And I was working with primarily 1 through 5 at that time. And through that presentation, the district brought back some of the educational technology funding. Unfortunately, it was only like 8 hours a week or so for people in my position. So that wasn't quite enough to work on. I was then recruited into private schools and I taught there 3 through 8th grade technology course. Teaching kids everything from video production to MS Office Suite to typing. One of my biggest teacher accomplishments actually deals with a student with Downs and teaching him to type. I really take a lot of pride in that.
That's great.
And then I was looking for something a little more where I could help design curriculum. So I ended up getting a position at Bishop Montgomery High School, and I'm their Educational Technology Curriculum Integration Specialist is my official title. But as Shannon mentioned, I teach an AP Computer Science course. Essentially, I'm their Ed Tech Director or Ed Tech Coordinator, however you want to say it. So my main goal at Bishop Montgomery High School right now is to help teachers develop curriculum that integrates technology, but also just to increase the overall saturation of technology on campus. and try to put coding into different classrooms, try to do 3D printing and different activities, things along those lines.
And during that whole time, you did go and get formally educated in education.
Yes, I certainly did. Yes, let me back up.
Let's make sure we give you some
start
credit.
there, but yeah, I have a credential in industrial and educational technology. I have a master's in secondary education, a few certifications. I have a certification in andragogy, professional learning leader.
That's awesome.
Yeah.
Thank you.
And so now, do you teach a class by yourself, or do you just go to the other teachers and help them develop and integrate technology?
Yes.
Yes.
I do both. I teach a one period of AP Computer Science. I'm very proud. I had a 90% pass rate last year. So
congratulations.
Thank you. I've been doing that class for about, I guess this is my 4th year. And then I also help teachers with technology in their own curriculum.
And what subjects do you assist the teachers?
Across the board, the entire high school. English, math, world language, everybody. I try to increase the use of technology throughout the campus.
And they are a one-to-one Chromebook school. It's a BYOD.
Yep, we're a bring your own device, one-to-one Chromebook school. I really try to do projects that are all Chromebook accessible. A lot of the stuff I'll be talking about today can all be done on the Chromebook. A lot of the programming that I do, we do it on the Chromebook. One-to-one Chromebook school. We do have PC lab. We have a Mac lab. We also have a fleet of various tablets, but primarily we use Chromebooks on our campus.
So your school requires that the students purchase the Chromebook?
So as a incoming freshman, or whenever you join our campus, it's just part of the requirements. We give a couple of suggested devices, but we really like Chromebooks because we have a wide range, huge demographic, about 30% National School Lunch Program. So Chromebooks are very affordable. They're very easy for our IT department to deploy. They're very easy to manage. They're easy to fix. So we decided a couple of years ago to go with Chromebooks. And yes, so students can buy any Chromebook that they want. Like I mentioned, we give a couple of suggested models, but there's a wide berth out there of different Chromebooks. We get the entire range. Some students bring aluminum body touchscreen Chromebooks, and some students bring the Chromebook that their sibling just graduated with. So it's on its 5th year.
And it's really cool. The way they rolled it out was 4 years ago, I guess. This current seniors were the first ones that had it. Everyone brought it. And then the next year, the next round of freshmen came in. So there were freshmen and sophomore. And then the next year, three grades. And then this is the first year where every single grade is fully deployed. So it just allows for more opportunity in every single class.
It really does. It was a really good way. It had its pros and cons. It was a good way for us to do our deployment and slowly build on the technology that was in place on campus. It just got bigger and bigger and bigger, and the opportunities became more and more each year. It was a little difficult of a transitionary period, though. Some of our teachers had a tough time having, in mixed classes where seniors weren't necessarily required to have a Chromebook, but the juniors were last year. I had a fleet of Chromebooks that we could disperse and distribute into the classrooms when we needed. And now we don't. Now we don't.
Right.
It's pretty cool.
So the bring your own device, do you feel like the students take better care of the equipment, or do you think it really matters?
There's a lot of ownership. Because they own them.
Right.
Don't think I would necessarily sit on one side of the fence or the other. We get a lot of devices that are, I think it just kind of depends on the person and, what type of person are you? Are you somebody who throws your backpack around, or are you a little more organized than that? But on campus, we do basic repairs and stuff for the students. So if you do crack your screen, we'll ask you to purchase the replacement LCD, and then our IT department will swap it out. We do various small repairs. If it doesn't fit within the scope of something that we're comfortable repairing, then we put the burden back on the student, and we say either pursue a warranty repair if it's available, or go buy another Chromebook.
Right.
Yeah, it happens on occasion, but I would say a very high percentage, the majority of our Chromebooks last through the 4 years. Most times, screen cracks are pretty inadvertent, and that's about a $30 to $40 repair. So it's not the end of the world.
But did you ever get a tech club together? I think at one point we had talked about like the students being a tech club.
I was going to mention the funny thing about students sometimes and cracking their Chromebooks is they're not always upfront about, whoops, I made a mistake. So
really?
Sometimes I'll be walking around the library or through a classroom and I'll see a kid trying to work on a little small quarter or third portion of his screen that still has legitimate like images coming up on it. And they'll try to make do, and I just tap them on the shoulder and say, hey, let's fix this. It's not too bad. But we have a technology and programming club at Bishop Montgomery High School. The primary goal in that club is really to help students, the idea of doing service for the community, the idea of the design process, and what do you want to create as a student. There's a lot of repositories of models and projects that we'll talk about, but it's really easy to say, hey, go browse this website, try to find some sort of project that you're interested in. And my goals with the Technology and Programming Club is really to help those students bring those projects to fruition and completion. Right now, we have a couple of different projects going on. We have an open house coming very soon. The students are working on digital name tags right now. It's a 2x16 LCD screen. It's got a little Arduino Nano attached to the back. And they're working on specifically with 3D printing right now, they're working on refining the case to make sure all the components fit in there. They did a great job of that. They've got the window for the LCD to stick through. And then they realize that, we need to pin this to our shirt somehow. So now they're trying to do the revisions of how can we really quickly and easily get some, what do we call those little like clothespins? Pin like a safety pin. Yeah. So they want to use safety pins to do the attaching to the shirt.
That's kind of what we wanted to talk to you today about, was how you're using these 3D printers, because I'm not exactly sure when 3D printers came to market and we started seeing them at the ISTEs and the Qs and the conferences that we were going to, was like, I just don't understand how this is going to work in a classroom environment. I think the models the gadgets and things that you brought to us today, which we'll take a picture of and put on our website, is really cool. And I was even thinking this is cool for high school, but even younger kids figuring out geometry, putting this together in the elementary space would be really cool. But I really couldn't wrap my head around 3D printing in education. I got we could build a hand and give it to a kid with no hand. And I get we could tie those back to standards, but I was really curious as to, because you have a couple of 3D printers at the school.
We do, yeah. We have two what are called FDM machines, or two machines that you would traditionally think about as a 3D printer. And then we have one really nice machine that was donated to campus. We have a Form 2 from Formlabs, which is a special type of printer. It uses a photosensitive resin and a laser to harden the layers.
You have these, and how did you think about bringing them into the educational space? Was it your class? Was it other ideas? How did that come to be?
It really kind of started with other ideas. I think 3D printing in education, if you want to start generalizing, can go down two different paths. Physical manipulatives for the classroom, like Realia, or lessons where you're introducing students to modeling, you're introducing them to that design process, kind of tapping into their creativity. So I really try to focus on the latter, having students introduced to different types of 3D modeling, having them make specific objects, or modifying templates. Modifying templates is a great way to get kids into it. And then, just continually refining and putting out a project. So Realia is exceptionally easy to start printing if you have a printer available to you, like these geometric connectors that we brought in today, or different Realia that I've done, different government buildings. We're printing out the Capitol Mall for one of our AP US History courses. But those models would be applicable anywhere. Other physical manipulatives that we've done this year in our art courses, they get a little upset if we're bringing in nude models to a high school. So we ended up a Catholic high school. So we ended up printing like a 3-foot tall statue of Venus. We printed some 3D scans of different hands, just to give students those still life models, for their art projects.
When you're doing that, are you doing cross-curricular opportunities? In other words, are you taking your computer science class and they're making the models and printing them for the art class, so that you've got kind of this crossover of curriculum, or is it are you just taking the lead on that right now?
Right now, I'm taking the lead on that, but it's something that I've been thinking about and like to train more and more and more students. Unfortunately, I don't really have a space right now for setting up 5-6 printers and having students kind of running the show. But there is enough ready-to-print models available online that you can download and print immediately. I did not design these. Downloaded something really quickly and just pushed it out to the printer. There are so many things out there that teachers might be interested in, different sorts of teachers from different departments, that I think it's a really good asset. It's enough. There's enough things out there that students could be using those models as their training prints. Mm-hmm. If you don't have anything in particular that they're interested in printing, but just a way to open the door. Hey, this teacher down the hall needs this print. Can you run it for me? Can you do it? Can you get us a good solid print? There's all sorts of things that can go wrong in the print. So it's, if you need something to print, it's a way to get students going. But there's a lot of different repositories of 3D models that just download, send it straight to the printer.
And one of the things I was going to ask you was, like, we've done at LMU, we have a 3D printer. We might even have a few of them, but the one that I had access to, we printed a heart, and we were doing a presentation and on different virtual reality and things like that. And so one of the things was we printed this heart, and then the heart had a defect. So we actually printed the heart with a defect. And then we were like, you could take this to your anatomy class or a biology class or a pre-med class and be like, okay, this is a heart, a human heart. What does this human heart have wrong with it? And you could print 8 different hearts with 8 different ailments. And the students could look at each heart, whether it's dissected or whole, and they would have, like, that could be the test.
Right.
Which heart has a defect.
And the beautiful thing is you probably didn't have to actually model those hearts.
No, we downloaded it off.
Yeah, that's what I'm saying. There's so many different areas. Like Yale has a lot of different resources for biology courses. Yale has different organs. They have an interesting repository of models for, like, neurons in the brain. So you can print these, microscopic things in a large manipulative sort of way, something that you can hold and look at and examine.
So cool.
Yeah. So can you give us some examples of other classes, like, say, English language arts class, and what they would use a 3D printer for, or a foreign language or math?
Sure, yeah. So something I've done recently, like in a history class, we provided students with a template, just a really basic coin-looking template. And then the students went online and they found images. We converted those images into 3D models. Very easy. It's not hard. And then the students then modified the coins to make their own representation of a coin from that period. In math, something I'd like to do, I haven't done this project yet, but we can do a modeling project, for example, where students studying, like, surface area and volume might have to create a 3-dimensional shape that has surface area and volume of equal values. And then they can support that further with, their equations showing the equivalency.
You said, have you done anything with the foreign language department?
Foreign language department, I've not done any so, like, again, it comes down to modeling and then just physical, not to minimize it, but, physical things that you're putting into the classroom. So again, I really try to focus on curriculum or class projects where students are starting to do some modeling. At a little higher level, like a little more intermediate level of students. And the other problem is, working with in my position, working with such a wide swath of students, you have different ability levels. You have students who've never done any 3D modeling or any 2D modeling or anything like that. So you really need accessible, quick, one-off sort of lessons where you're not going to be taking up more than 2 periods of time, tops. You have some students with a little more experience. So maybe in a club setting, I taught an architectural design course years ago, and we were able to do a couple of more elaborate prints of, like, floor plans and things like that. My students, fun little project that we did was in my architecture course a couple of years ago. My students had a project where they were to model a single family residence from their, I don't know how to say this quite exactly, but, like, their ethnic origins.
Okay.
So, like, I'm like Germanic or something. So like what's a single family residence look like in Germany? More of a traditional sort of home, not some contemporary art.
Right.
So we got some really amazing models of, I had some Korean students doing like the like sloped, like
really
thatched
cool,
roof.
Very cool.
And then we printed those models.
You do that in a foreign language class.
Yeah. In foreign language classes, though, it's been, up until this point, it's been more of the realia that I've put into those classes.
Mm-hmm.
That's cool.
That is really cool.
Another thing I'd really like to do in math is outside the scope of my high school, but I've been looking for 3D models of sine waves, just different things that you don't normally see in a third dimension.
Mm-hmm.
Right now, I'm printing for a science course a full set of Bohr models of electron orbits for atoms. So it's just basically, it's a very small model with some information about the element, a couple of raised dots around a rotating edge that, those dots represent the electrons. So just a different way for students to kind of put it in their hand and experiment, more realia.
It's an opportunity to create a manipulative for something that maybe has never been able to have a manipulative before. Because it's either so small or non-visual without special equipment. Very cool.
Yeah.
So you make it sound so easy.
It really is. It really is.
There's different software that I know is available because I've played around with some of them. So there's different software. So if I'm going to build a building, a scale model and I don't want to use a template, let's say I'm going to do the Eiffel Tower in Paris, and I want to try to mock this up, or I'm going to do a building. I'm going to do
Sure.
How would I even? I'm a teacher, and I'm thinking this is really cool, and we have a 3D printer, and no one's using it. How do I get started? Yeah, go, right? Like what does that look like? Because I know there are schools that have these 3D printers that have been donated or as part of their STEM lab, and like no one knows how to use them. So where would we start if that was a thing in these schools?
Sure. So a couple of points. You mentioned by chance the Eiffel Tower. There's a neat little third-party application. There's a couple of them actually that you could use. I know you're a fan of Minecraft.
I am.
Anything that you build and make in Minecraft, you can easily export and print.
I did know that.
Oh, did you? Oh, I didn't know.
But we haven't told our audience yet. But I just learned that the other day when I was meeting with my Minecraft team. So
yeah. So I mean, that's a really easy.
That's so cool.
Yeah. One thing, I don't use Minecraft on our campus really that much.
Yes.
I think it's got a ton of value. Don't let me, don't take it the other way. But I would like to, and I'm just thinking about ideas that you can do. I really feel like the Minecraft world is a series of like same size blocks, right? Mm-hmm. It's like a standard unit.
Yep.
And when you use these applications, you're essentially exporting to where those blocks are like centimeter cubed. So I really feel like you could make kind of like a interconnecting sort of series of buildings and kind of like a little main street out of your class. It would take a while to print. But that's one quick and easy way. Talking about buildings and printing those sorts of models too. When I was doing it in my architecture class, we were using SketchUp. It's a really easy and accessible 3D modeling program. And my students were doing floor planning, just extruding, and then we can export that as an STL, a file type that you need to then process a little further so that you can actually print it. So the process is very simple. The idea is you get a 3D model. Either you make one or you download it from the internet. You then need to save it as like a CAD file. The most commonly used is an STL file. You then use another application to slice the model. And essentially what you're doing is you're taking a model, an object, and you're cutting it up into many horizontal layers of whatever thickness that you set in the program. That then is saved as a series. It's saved as a text file, essentially. It's a programming language called G-code. And it's like a numeric control language. And basically it's a series of X, Y, and Z coordinates, just telling the hot end of the extruder. It's telling the machine where to go. Mm-hmm. And it will slowly build up your model. So that's the process. If you were a teacher with no experience or anything, there's all sorts of software out there. I really like online tools because, I'm a Chromebook school, so we like to do things in the browser. I used to not be a very big fan of Tinkercad. Tinkercad is a site that's been put together for 3D modeling. I think it's Autodesk. Mm-hmm. And I used to really not be a big fan. I came to the game with some prior modeling experience. I used to do SketchUp and things with kids in like 5th grade. So I used to think that Tinkercad was pretty rudimentary. They've done a really good job. It's still fairly low level, but they've done such a great job recently of like developing some tutorials. When you first create your account, they take it through a couple of steps of how to do different things in the program. But that's a great spot to start. Anything you can make in that application online, you can then download and immediately print. So when I'm talking about walking into a classroom and, for a period or two and having them modify a template or something, most of those templates and most of those projects are done through Tinkercad. It's really easy. For example, I did a project where I gave students like a cube, maybe 2 inches tall, a rectangular box, like 2 inches tall, maybe like an inch square at the base, right? And then it had a little recess and the cube would stack. One cube would stack on top of another, right? Do you remember in math class, those little plastic counting?
Oh, yeah. Manipulars, the math manipulars.
Yeah. I don't remember they're kind of like Legos. Anyways,
like Legos.
That was my inspiration. These little boxes stack up on top of each other. And my original intention for the project was to have students modify each box. I can disperse the template across the classroom, and then they could add images and to the different faces, to the different sides. And in the end, we would have like a classroom totem pole representing, the different kids and the different personalities in the class. My religion department has taken that project and they do symbology from the sacraments. Mm-hmm. And so we have a bunch of little models that stack up. So essentially students log into Tinkercad, they get the template, they then jump on Google Images and start searching for different images. We guide them to not like real life pictures, like simple things, right? Mm-hmm. We want symbols. We want basically like monochrome images, pretty much like clip art-esque things. Right. So they find what they want, then they can convert it, JPEG, PNG, whatever it is, to an SVG file, a scalable vector graphics file.
Very good.
Thank you. And there's all sorts of ways you can do that. Pick to picsvg.com. So like pick to svg.com. Great resource. You can just upload your file, download your SVG file. And then in Tinkercad, you can just import that file. You can set your dimensions. So we're working with like a cube that has like a width of like 30 millimeters. So we can just change the width and then twist it and place it and group it and print it. It's really quick, really simple, very accessible. And they're starting to be introduced to manipulating 3D models, merging different things. We can start throwing a lot of different jargon at them, and talk about what a mesh is, or, whatever it might be. And that really takes about a class period. You can do that with anything.
Right.
Anything.
And it takes about a class period to do all of the little...
Not print.
Oh, okay.
Not to print.
Got it.
Just to make the files. Mm-hmm. And at that point, what I've been doing is just collecting the files, running back and printing them in my office or wherever I have a printer set up. One of the nice things is they're really small, quick prints. They don't take much more than like 15, 20 minutes per item. So it does stack up with time, but it's a couple of days later, you can go back and hand them out to the kids.
Mm-hmm. And about how much does that cost to make one of those little cubes?
It's incredibly affordable. 3D printers, let me ask you, what do you think a 3D printer costs?
Up the printer?
How often you get the questions thrown back?
Yeah.
All right.
Wait, what?
Yeah,
He's flipping the
interview on us. My guess is... I'm going to let you answer because I think I probably have more.
You may have a little extra knowledge.
Yeah, so I'm going to let Brenda answer.
You may know the answer. I don't know.
Okay,
what do you
so
think?
I actually have
and
not even...
And there is a wide range.
I bet. Okay, so my guess is about $2,000.
Okay. You could buy a very, very nice 3D printer for that.
Okay.
Yeah, I'm thinking on the low end, you're at $1,500 for the printer, and on the high end, and not for like the big, huge laser one that you guys have, but on the high end of a desktop laser printer, I think we'd be in the 5,000. It'd probably go from 1,500 to 35 to 5,000. 3,500 to 5,000. That's my guess.
If we're going to talk about the real high end, you can push around $10,000.
I think even higher too, probably.
You likely could. And there's a whole mess of different types of printers. We can talk about different types of printers if you'd like, but primarily we're talking about like a spool of plastic, right? What you've seen at the conferences.
Like the filament.
Yeah. It's an FDM printer. The analogy is always like a hot glue gun. That
right.
You're just kind of building up layer by layer. No, you wildly off.
We're wildly off, Brenda.
I've been told that before.
It's pretty common for us.
No, we have 2 machines on campus that you could buy right now for $270.
Wow.
We have a nicer machine that we bought just a couple of weeks ago, a much larger build volume that runs about $450. Really, you shouldn't be going too far outside of that range per machine. Each machine runs off of a spool of filament. That spool of filament can vary in price as well, but usually you're spending a little less than $20, $17 to maybe $22, $23, depending on the brand. And that spool of filament, that kilogram of filament, lasts a long, long time.
And you can have different colors.
It's one of the nice things about FDM machines. You have a full range of colors that you can work with. There are some things that you can do with other machines to add some coloring in. But you have a full range of colors. You have exotic materials that you can print with. One of our printers is set up to print in 80% copper filament. So we're actually printing in copper, essentially. It's polishable. It's cold. It's heavy. It's if you're sanding it, it's got like a little bit of a sharp edge to it. It's really kind of neat. You can print in woods, nylons, carbon fibers, different types of exotics.
Why was I so off? The prices have come down then significantly.
Prices have really kind of plummeted over the last couple of years. A lot of companies still are charging many thousands of dollars for printers. If you think of 3D printers, there might be a couple of names that come to mind. They're usually a little more expensive.
Right. Or in the options, right? That'll definitely bring up the price.
If you can print in 2 filament, like at 2 colors or something, then you're...
Dual extruders are a little more expensive.
That was what I was going to say, dual extruders. But I said 2 colors, so it's fine.
Well, there's not many benefits to having 2 extruding heads where you're melting plastic and putting down 2 different bits of plastic. Not at the same time, but almost. But one of the really neat benefits is if you're printing complex, yes, you can print 2 colors.
Okay, thanks.
Yes. But one of the other neat things is you can print with different materials.
Okay.
So one of the problems with 3D printing is support structures, depending on the complexity of the piece. If there's an overhang that past about 50 degrees or so, 45 degrees maybe. If there's an overhang that steep, your printer really has a hard time putting down the next layer. There's essentially nothing to print onto. So slicing programs, when that scenario arises, will put in support structure. So basically like a pillar of plastic printed purely to support the main model. Well, with dual extruders, one of the cool things you can do is you can print in what's called PVS. And essentially it's a material that's very like akin to a glue stick. Mm-hmm. It's like the same stuff a glue stick's made out of. But the neat thing is that material is water soluble. So you can print these support structures in a totally separate material and then just take your whole model and soak it in water for a little bit, and all these support structures will melt away, versus leaving maybe potentially some plastic. If you're not using this soluble material, some plastic that might like stick to your model and kind of not make it look as clean as it might.
And then you have to like sand it down or whatever.
With these printers, I don't do too much like post-processing. We try to clean them up. If you do have any like stray bits, try to like clean them off and, make them as nice as possible. But you can sand. You can, sometimes people use like a filler to kind of fill in, because you sometimes see lines from the print. They're easily paintable. Another really kind of manipulative that I've done in the past, back to art, is other small statues or shapes, or like they have like these low polygon animals. my kids like to take those and, paint them or whatever it might be. Some elephant or hippo or something.
Cool. So they're making like back in the days of ceramics, which they're still there.
A sculpture,
and then they paint it.
Yeah, essentially just some sort of like a blank, and then they paint it up however they want. Speaking of ceramics, we have another type of printer on campus. So we have these printers that work with the spool of filament. And essentially the idea is that it feeds it through. There's one spot that gets really hot, melts it, and then you want to solidify the filament as soon as possible. That builds up. Those are FDM printers. We also have what's called an SLA printer. The SLA printer works with a liquid resin, and it's UV sensitive. So basically under ultraviolet light, the resin will harden. I had to move the printer the other day. Just a quick little anecdote. I had to move the printer. So essentially there's a tray of this liquid inside. I took the tray out of the machine and walked it, let's say a block. In that time, it filmed over. So this stuff is very sensitive to UV light. It filmed over kind of like if you took like a dollop of glue and just kind of let it sit on the table. Kind of squishy inside, but you got that hard layer. Mm-hmm. So this other machine, the Formlabs machine, the Form 2, it uses this UV sensitive resin and a single laser, and it kind of works in reverse. The FDM machines have a build plate that is built on top of, and then the model is continually built on top of. The SLA machine works by having the build plate upside down, and it dips it into the vat of resin, just about to the point where there's a layer's worth of space at the bottom of the vat. And then it uses a laser to trace your layer, your pattern, whatever it might be. It's exceptionally high detail. You can get really, really clean, crisp prints. However, thankfully this machine was donated to our campus. But the downside to me is it's almost prohibitive for a school to have a machine like this because it's so expensive to run. That resin is essentially about 16 cents per milliliter when you're printing things. And that adds up really quickly because also this machine only prints solid objects. So you really got to start thinking of the law of cubes, right? So like a 1 by 1 by 1 centimeter cube has a volume of 1. But if you just double that, so now you have a 2 by 2 by 2 cube, your volume's gone up to 8. So that can really chew through a lot of resin. I use that machine on campus for kind of final drafts. I really like to get students modeling, revising, that design process. So we use our FDM machines as kind of draft machines, get something printed, check your sizing, check your shape. And then once they finally have a final draft, we'll start running it through the SLA machine. But I started talking about that because you mentioned ceramics. The SLA machine also has some exotic materials that it can print with. And one of the newer materials is a ceramic material. So the liquid essentially is a ceramic. You can print your model. It's then, I believe it's glazable. I know it's definitely fireable. I can't imagine it's one without the other.
Right.
But I think that's amazing.
That's really cool.
Yeah.
That'd be fun to at least build some small, at the end of the prototyping process, build some small models and have the ceramics teacher see.
Yeah, we have a couple of kilns on campus. That's something I've been looking forward to discussing with our ceramics teacher. Yes, let's do the wheels and let's make coil pots and things, but let's also introduce a little bit of 3D modeling where maybe they can make some shapes they couldn't with their hands.
Right. I know that I still have some my pots that the lids don't fit quite right from when I took ceramics 25 or 30 years ago. And
so you kind of just touched on another really great idea that I like. You have a design problem. You have a pot that you want to keep, that you want to use. Is it sentimental? Is it a ceramics product?
Yeah. From
Definitely.
High school. From
totally
the
sentimental.
late 80s.
Definitely.
Wait, Shannon, you just were telling me yesterday you're not...
I'm not sentimental, but I have this one pot. I was telling you that exactly. I have this one pot, and the lid doesn't fit right, and it has my name on it, and it's cool. It's our class colors, which were blue and black. I went to Bishop Montgomery High School, so I know the ceramics room very well. But and so I have one thing that I kept. I don't have my sweatshirt, but I've got this one stupid pot that's traveled across the country with me. But yeah, but it doesn't sit right. And
well, there's a school back east where I first saw this. Just a website I strayed across a while ago, and they had a problem bank. I really like the idea of a design problem bank, and the idea being like Bishop Montgomery could have a small section to our website, or just create another website or something along those lines, and people submit things that they have a need for. You have a need for a oddly shaped lid for a pot. And, we could have a student figure out how to make that object. It could be anything from like, oh, my table
wobbles.
Like, yeah, my table wobbles a little bit. Like, could you design a new foot for the leg of the table? Or
that's so cool.
Yeah.
I love that idea.
I love that idea.
Right.
Yeah.
Okay. I'm going to bring all my stuff to you.
Yeah.
Doesn't fit, doesn't work.
Need a new lid for my pot.
Right. So
Berkeley kind of has a cool program too. I don't know too much about it, but it's the same gist. It's just at a much higher level, and it's primarily for assistive devices. It's called Enable Tech, from Berkeley.
That's very cool.
But I'm a big proponent of the design problem bank,
right. And I was going to ask you about that. And so, is there a process that you go through? Say the students are designing something, and is there a way for them to check to see if it'll actually work before you print it? Or do you print it like a sample first and then say, oh, there's a design flaw right there. We need to fix that, and then do it again?
Well, they're not exactly just making something and hoping it fits. There's a lot of measurement and a lot of there's quite a bit of prep work before you start doing something along those lines. I always have tips as students are going through a project like that, through some sort of modeling. Something that frequently happens, for example, people misjudge how large a millimeter or 2 millimeters is. And by how large, I actually mean the opposite. How small a millimeter or 2 millimeters is. Like somebody will be designing a case or something like that, and they'll put like really thin walls. So just things along those lines.
Or I'm thinking like, say, Shannon's thing that she made. So say she made a lid, but it didn't fit perfectly.
Oh, sure.
And
Bring it back. Let's do it again.
Right. Yeah. But even say you made the lid, but it's really a little thinner than what you thought it was going to be when you actually put your hand on it. And so then you think, oh, I really like to be, instead of a 1/4 inch high, I want to make it a 1/2 inch, or I know.
Time to revise.
Right.
Yeah.
But I mean, is this something that you could do easily?
Oh, 100%. Yes. Okay. I get what you're going. Yeah. Yes. Your model, you just get back into the model and make whatever adjustments that you want. Mm-hmm. Depending on the program, the adjustments can be easy or not. If you're using something like OpenSCAD, which is like CAD scripting, that can be super easy to just, modify like a value for an attribute. If it's something like Tinkercad, it might be a little more difficult. You might have to start pulling some pieces apart to make whatever adjustments that you have. So depending on the ability level, you might go about the revisions in different ways. Mm-hmm. But yeah, definitely you can revise.
So I can also come to you with all of my inventions and say, I'm thinking about doing this. And how easy is that for me to like sort of just sketch something for you and for you to help me make an actual model?
You might be a little ambitious.
She's a lot ambitious.
I'm very ambitious.
A little ambitious.
But that would be, I think that goes into the problem bank with the kids.
Right.
Yeah, and the problem bank could have, various levels of difficulty. What Brenda's talking about is more of a full-on
like a prototype
CAD project.
Right.
That would be something a little more advanced. Something I'd probably do in like a club environment. Okay. There would be a lot of prerequisite knowledge of not just modeling, but also like CAD use.
Design.
So, yeah.
Okay. Well, now I know where to go.
I think the biggest part of this whole interview that's fascinating to me is the cost. Right. I mean, I remember having a conversation with you about like doing a GoFundMe or a Donors Choose or something.
We did talk about that one.
Right? Back in the day, and it was like $3,500.
We were looking at machines, I think right around about $1,000
okay.
or so.
So maybe we were trying to get two.
Could have been, multiple machines.
We were trying to do 2 machines with filament And I think we were talking about 3,000.
Machines have fallen drastically. If you're interested in just getting something for your home, you're maybe looking at a smaller printer. Again, this would be like a smaller machine. Maybe not. Probably can't print objects bigger than like maybe 3.5 by 3.5 inches and maybe like 4 inches tall. But you're probably going to spend about $160, $180.
That is insane.
I know. Obviously, there's some filament that is stronger than others.
There's different types of plastic. So this is PLA. These little bits that I brought in today. PLA is it's a non-toxic plastic. It's made primarily out of like cornstarch. If you read up on it, it says it's safe for food. Do not eat anything that's been printed. Don't use PLA for food.
It's not like a fork. Don't
use
forks.
it as a fork. I mean, the problem primarily is like this is a bunch of layers, and often it's hollow. It's not entirely like a solid piece of plastic. You know, you might get bacteria and stuff inside. Don't give PLA things
to babies
okay. to suck on and stuff like that. So
good.
Yeah,
it's just gonna get dirty. I imagine you've seen that like inside of something that a baby puts in their mouth after. So don't do that. But PLA is most often associated with like a water bottle plastic.
Okay.
You can print in other materials. Another common one is ABS. It's just a different type of plastic. ABS is often associated with like Lego plastic. So it's much harder. It's requires more heat to print. It's much more finicky when you're printing. I do not do much printing in ABS anymore. It's kind of a pain. You really need to like capture your heat so that you have nice heat distribution throughout your print and things like that. PLA or ABS loves to like curl and warp. Your layers will separate. It's really kind of tricky. Little side story I read recently that Oregon State University and their like printing facility, their library or wherever they have it all set up, they no longer print in ABS because they apparently ran some tests or something. They found more particulate matter in the air by a factor of many.
Right.
We're talking like 1 to 100 or something like that. And ABS tends to have like a little bit of a smell to it. Some people that are a little more sensitive might get headaches or just not find that pleasant. So yeah, there's all sorts of different types of materials. Like I mentioned, we can print in exotics. So depending on the machine and the setup, those exotic materials can get pretty expensive. My 80% copper, my copper filament, for a kilogram of that, it was $80. Versus like $17 to $20 for a kilogram of just like plastic like this. So, but it's very, very strong. I mean, if you're printing solid pieces, they're brittle. This type of plastic's pretty brittle. But just talking about different materials, they have flexible filaments as well. A lot of people really like flexible filaments. I haven't had a chance to really walk down that path myself yet, but flexible filaments apparently for like toys and stuff for kids are just amazing because it doesn't have that brittleness, and if you drop it, it's not going to crack, or a kid can really stress test it. So
that's so cool.
I know.
I can't believe the price point. It just baffles me. And then I'm thinking like, okay, so if this is some of the stuff you can do in a classroom setting, really applying it to the standards, and depending on, that's your primary job. His primary job is to go in and work with the teachers of like how to take some of these traditional non-digital lessons and add basically some coding, modeling.
Talking about ceramics, right?
Ceramics,
Yes, you've done it like this for years.
Hundreds and thousands of years.
Slip in a little modeling.
Yeah.
It doesn't take long, but kids can, if it's something that they're interested in or something that they like, they're always welcome to expand onto it. My FDM printers at school are open door policy. If you want to put your name on the list, you're welcome to come and print. Those machines, I don't care if you find a model online or if you designed it yourself or if it's going to print for 10 hours. I just want kids, excited and knowing that they have that opportunity.
How are you getting the words out to them? Like how?
I get a lot of it is just straight one-on-one contact with students.
Okay.
My office is in sort of a way that I get a lot of foot traffic through my office. Kids are always just fascinated. And anytime they see a machine running, I have a sign-up sheet that we've distributed to all the kids. So if they want to put their name down, they're more than welcome to. But most often it's just like somebody will come and need a little help for some other matter, and they see these machines running, and they're like just fascinated by it. It's really fascinating. I will sit there and stare at that first layer. Like it's amazing. It's really amazing. Cool. It really is.
And what could you do? So homeschool folks, I'm thinking the
printers aren't as expensive.
They're not
as they used to be.
So this is a great opportunity, like you were saying, for a couple $100. This could be in someone's home as a homeschool.
You could have filament and a printer for right about $200. Monoprice is traditionally a cable company. And somebody in my position, I bought cables, many cables, like so many cables, HDMI cables, Ethernet. Monoprice has always sold cables. And they, over the last couple of years, have started selling other things. And one of those other things is 3D printers. My understanding is they're essentially rebranding other machines, but they have exceptionally reasonably priced machines. I have 2 of their Select V2s on campus, their Maker Selects. Those machines right now are $270. It's a great jumping off spot, in my opinion. Some of the cheaper machines, some things that make your life a little tricky. I've used their Select Mini before, and it's just to compare, which is $150 or so, maybe 180-ish. But to compare that machine to a machine that costs another $100, your build volume is like twice as much. You can achieve higher temperatures, so you can print different materials easier. Just the design of the machine as a whole. For example, the Mini, you have to bed leveling the build plate of your machine. It's an important factor. It really is. A lot of new machines nowadays do auto calibration, which is really cool. I haven't had a chance yet to play around with one of those, but that would be a lifesaver.
Right.
It's just a little thing you have to deal with or check before you print something. You need to make sure that the place where the hot plastic is coming out is the same height, all across the bed. But the cheaper machines, like you might have to get out an Allen wrench and, kind of adjust from the top angle, which can be a little awkward sometimes, versus another $100. And you can use like wing nuts on the bottom, or another couple of $100 and you can get an auto leveling machine. They actually have a machine, I think about $180 Monoprice, that does auto leveling. They have a new model. It's a Delta printer. It's the same type of printer. It's an FDM machine, but the way it moves the head around, the printing head, is a different mechanism. It's kind of like suspended by cables as opposed to being on like a rod.
That's cool.
But you can get those for $180, $200, and you've got an auto leveling machine.
And thinking about, the price point for a homeschool, the price point for any school is really easy.
Mm-hmm.
The other thing I was thinking about homeschooling is kind of going back to what you were saying, is there's things that we have in the home situation where you just want to fix something, but like you don't have the right part, or you don't have the...
I've done a ton of that in my own home. And it's such an accomplishment.
Is it?
It feels so good.
Bet.
What have you done?
It might end up taking you a while to design and refine and make something work.
But you did it yourself.
It is so...
It's great. So cool.
What's an example of something you've done?
I've done a lot of stuff, like little door catches on, like replacing my cabinetry, that little ball and receiver sort of thing.
Mm-hmm.
I've replaced those. I've got a friend who's done some really cool stuff in automobile restoration.
I have a cousin who's been doing some 3D printing in the automobile restoration phase.
This guy that I met during an AV installation at my school saw my printers running, and I was like, oh my gosh, that's great. What do they cost? And I told him, and he was like, oh my God, that's such a reasonable price. And he was telling me that he's working on a classic car with his father, and there's just plastic components that have degraded over time, and they're hard to locate, or you can't locate them. So with zero experience ever modeling, never had run a 3D printer. Within a couple of months, he was putting out parts and then selling them to other
smart
people at $10 a pop. So,
and you get a little cut of that?
I feel like I should, right? I feel like I should get a cut from Monoprice.
Little something. But my cousin does that too, because he restores these classic cars, and oftentimes you can't find grill pieces or decorative pieces that go kind of in some of these. They have special inlays, and you just can't find them anymore. So he's been 3D printing them. And
there's a wonderful subreddit out there called Functional Print, and it's just tons of, it's people with 3D printers in the home and things they're proud about that they designed and made.
That's so cool.
And it really ties to the idea of a design problem bank too, right? Mm-hmm. It's just a smaller scope. One of my buddies runs Ironman competitions, and he wanted some medals. I printed him a couple of medals out of copper.
So cool.
Another friend of mine does event planning, and they had a specific logo for a company. They wanted to have like a dessert with powdered sugar on top and in the shape of the logo. It took 10 minutes to punch out a blank, negative space image of their logo and just print 2 or 3 layers thick, and you got this little flexible thing that you can plop on top and dust over.
Wow. My mind is like going 100 miles an hour.
Yours is.
Yeah.
Mine's just exploded. Brenda's like, we are going to get a 3D printer
I know.
in here, and we're going to start printing things.
Totally.
I don't think they're quite they're not to the design point yet where 3D printers are going to like replace microwaves or something, sit side by side. But they are great. They really are. There's some caveats. I mean, they require maintenance. They require continual maintenance. They don't.
And what is the maintenance?
On a print by print, you want to be checking, is my bed leveled appropriately? There are so many options. So essentially, you find the model, you slice the model, right? In that slicing software, there are a ton of different options that you can tweak and dial in your printer. So once you get it dialed in, and if you're sticking with the same brand of filament, because not all filaments are the same, you can usually keep your settings going and churn and burn different prints. You do want to make sure that you're nicely leveled and your temperatures are correct and things along those lines. But long-term maintenance might be things like you might occasionally get jams or clogs, things along those lines. Really not too difficult to address once you do it a couple of times. And that Select V2 that I mentioned is a phenomenal to service. My tech club, I don't service them anymore. They're simple enough. I trained my tech club students to do it. So they disassemble the whole machine. They'll replace nozzles and tubing inside and all sorts of stuff, put it back together, and it works just fine. So you might get jams occasionally. That does happen. Or after maybe 30 days of continuous printing or so, you might start seeing as the plastic's melting, right? Like a little bit might not get pushed through. And as that's continually at heat, it'll eventually like carbonize into like black gunk. So you can get it to where you get these like occlusions in the path that your filament is taking. Sometimes maybe after 6 months, a year, you might have to pull that out and kind of replace some of those internal parts. Again, simple enough. I have students doing it. It's really not complex. You just got to kind of follow a couple of steps. Now, that being said, I did break a nozzle the first time I tried it. Like I did. I really did. One of the steps is you need to heat up the hot end before you unscrew a brass nozzle that everything comes out of. My brain was saying, if you heat it up...
how am I going to unscrew that?
Doesn't metal expand when you heat it up? Yeah. So I said, I'm going to ignore that.
Yeah, that can't possibly
What do they know?
Yeah. Snap. Immediately. So follow directions. And,
that growth mindset's really working on you.
Yeah. Well, I'm a strong proponent in learning through failure.
Yeah, that's the design thinking process too.
The things that you brought today, can you explain what they are and why they're useful?
Yeah, so I just brought you a couple of classroom physicals. I stole them out of our geometry class, and essentially,
but you're going to give them back.
Well, you can keep them. I can print some more. But they're just they're simple shape connectors, and the idea is there's the whole set has 4 or 5 different shapes, and the idea is you take a couple of them, give them to a small group of students, and challenge them to put the shapes together. Just a way to supplement your geometry discussion. So this is an example of classroom realia.
Now this is good. So you brought in connectors that are either
So we have a cube and we have a tetrahedron here.
Mm-hmm. And then you brought in pencils.
I brought in some pencils.
Some regular Ticonderoga
Yep.
number 2s.
Number 2 pencils.
That are not sharpened.
So, I mean, this could be set up to use wooden dowels. You can very easily like scale these pieces just to make some adjustments and fit whatever you want as a connector. I have so many pencils lying around that I love using pencils as a building component. They're cheap and they're a standard size, and yeah.
It's awesome.
I still think these could, I know you made them for your high school geometry class, but I still think these could go into elementary.
100%.
Yeah. I think that this is, this is real world. This is making something that's theoretical and hypothetical and 2-dimensional into 3-dimensional.
So another idea I've had with these sorts of connectors is I would really like to, like the classic STEM build a bridge sort of project and have limited resources and you can only use X tons of steel. Well, that's all right up in the air and it's all like
theoretical.
Yeah. We could say, here's 20 pencils and X amount of connectors and who can build the best bridge? Or something else that I've been thinking about is, in the modeling programs or in the slicing programs, you could say you can only use 10 grams of filament, span a 10-inch gap, or
be able to hold X amount of weight, right?
Yeah, and on top of that, and then you can get material to weight ratios and things along those lines. So
it'd be cool. There's so much you could do. I just really didn't see it.
Right.
I mean, you've opened my eyes. I mean, because I can touch it and see it now.
Right.
I mean, other than printing that 3D heart, which by the way took a ridiculous amount of time. I'll put the YouTube video on our website. It was like 11 hours to build the heart. And so that's the other thing that I think I wanted to talk about was because you've alluded to it as the time to print.
Time to print can be an issue.
It can be a long time.
It is not instant gratification at all. It is not. It can be a long time and prints can fail. Prints can go bad. How dialed in do you have your printer and how well are you maintaining it? But like these little objects, a set, maybe 30 minutes.
Okay.
Tops. Bigger pieces, the statue of Venus de Milo that was 5 different sections and 3 feet tall, probably 3 days total of printing. So the complexity of the shape, height has a big factor. And then also the density, the infill amount. So like these are solid pieces, still about 30-ish minutes. We could probably cut 10 minutes out of that if we, said make it partially hollow. But the tight fits.
Yeah, we were pushing.
We don't want those to be breaking. So
well, and I was thinking like another component, like for your video class on ours, when we did the 11-hour print, we set up an iPad on a tripod and we said don't turn off, and we hit it. I think we hit slow motion or fast motion. I don't know. But anyways, we
time lapse.
Yep. And then it's a 3-minute video that is 11 hours of, it's really cool. You can see the lights go out and you can still see it print, people come in and out. But it was 10 or 11 hours of printing.
So a great little supplementary piece of software is called Octo Print. And Octo Print is something that you can put it on a variety of things, but most people put it on like a little Raspberry Pi. And it's very easy to set up. It doesn't take a lot of knowledge. Again, follow some instructions online. And Octo Print will allow you to control your printer through a browser.
Wow.
Yeah, it's pretty neat. But also Octo Print has like some functionality to help you tie in cameras and do time lapses and things along those lines. A lot of people will like set up a camera and just to do a regular old time lapse, but the problem is you get movement or like where's the build plate, that sort of stuff. Octo Print will like only snap pictures when the extruder's off to the side and things. So you get really clean looking, time lapses of prints and things. Octo Print's a great supplemental little piece of software.
Free, because it's
free, totally free. Everything I'm talking about is free. Yeah, I am cheap.
Yeah, well, Catholic school teachers.
Yes. Welcome to frugal.
Yeah, I know you, and so I know what you're doing. But I how is this being communicated out to the broader community, or is it? I don't think it is really. You guys aren't.
No,
you need to sing this from the rooftops,
yeah.
like this. We're doing a lot with this kind of stuff, and it is embedded into these these kids' education.
In all honesty, I am not good at promotion. I do
We'll
not
help you with that.
I'm sorry. I feel like there's so many things to do in the day. And
I know.
I know. I don't often have time to say, hey.
I think, the school tweeting different photos of different things like this that the kids are making would just really help bring just an awareness from a parent perspective to, because I know the school's working towards being more of a STEM school and
definitely
integrating more of they have the new anatomy board. We
have a new anatomage table, which is a really kind of a neat device. It's essentially a touch screen that's the size of like a medical examination table.
Yeah, it's like 6 foot.
Yeah, it's a good 6, maybe 7, 8 foot. Yeah, it's huge. Big. It's huge. And it's all touch screen. And the idea is you have a cadaver. It's a real scan of a cadaver. It's, I believe, an inmate who donated his body to science. And there's a couple of different models. There's a couple of different people, different genders. And they have some animals as well. And the primary use is you can do dissections, you can do really high level examinations or really focused examinations of different components of the human body. So it's a way for us to have those higher level dissections as opposed to doing a cat or a frog. And
the fetal pig. I did the fetal pig back in my day.
we have those options, but we also have biology that's, human.
More virtual too.
Yeah.
And I'm thinking, so I see, I've seen some tweets and I've seen some posts that they're doing on social media for that, but I think this is just as cool.
It is.
I mean, the work that you're doing here is just as cool. That's more of the science component of STEM, and this is more of the engineering part.
So it's a lot of engineering. Yes,
yes. And I think that
little art.
It's definitely, it's art, it's engineering, it could be science. You could be building atoms and you are building different electron things. So this kind of can go into every single subject area, but it's a lot of E.
Tie on or to run parallel to science really quickly. I think it might be Yale, but again, just another repository. There's, universities out there have really cool repositories of models. Something I saw recently that I was going to talk to our biology teachers about was plant, like a cross section of a plant, right? Something like if you took a plug out the middle of a tree, but a very small plug blown up. So something that's like microscopic blown up huge. So you can see the vascular system. I don't know. Is that the right word? The vascular system of a plant. You can see all the different, the channels of how it's distributing its water and resources and things like that. So there's so many things out there. It's just, you got to start looking.
Yeah. Right. And I think if you don't know, if teachers don't know that this type of stuff is A, affordable,
right,
B, accessible, and C, can meet some of the engineering requirements that they want to do for STEM or STEAM, they could be hitting art and engineering and science. They could hit they'll hit all 4. They'll hit everything. They'll hit all 5 with this type of
math,
a product.
you're talking about
with the modeling is math and
specifications,
and it's using different technologies, whether it's open source or all the modeling software is all. It's the 3D printing, when done right, could hit all the STEM and STEAM components.
It does. It does. I'm not going to disagree with you. Yeah.
And yet we don't. I think it's just we're unaware of it, and it's under.
I think it's overlooked a little bit.
Yeah, overlooked. That's not over. Thank you.
It's pretty new. It's really only been accessible for a couple of years.
Yeah.
Printers have been around since the late 70s, early 80s, but it's consumer models.
Right.
Really, it's $200 machines, $300 machines, really over the last couple of years. And I kind of analogize it to, this may not be the most PC thing to say, but a lot of people have, in my opinion, a misconception about students and their ability to use technology. A lot of people think, students, they can just grab it and do it and they know it. No, that's not true. They still need to be trained. They still need to be taught. There's in my opinion, a lack of apprehension for them. They're not afraid to pick it up. They're not afraid to mess around with it, experiment. That's best way to learn, in my opinion. Whereas, somebody maybe from an older generation might be a little more apprehensive about like breaking it or, what can you do? And I think it's also true to 3D printing right now. They're really simple machines. They are not complex machines. It is dead simple once you kind of understand the mechanics of it. The process of finding models and preparing models and actually printing models is 3 steps. We're talking about finding a file online and downloading it, talking about opening that file in another program, talking about saving that file as a particular, like a G-code file, and then slipping that on like a SD card or something and putting it into your printer and pressing go. That's the process.
Right.
So they're really not big, scary machines. You're not going to burn down your house. You're not going to severely burn yourself or anything like that. Right. They're great. They're accessible and they're a ton of fun. And it's a great feeling of like creativity and design and, like I said, accomplishment, once you actually like put something out and you're like, oh my God, it fits. Yeah. Like it works. Wow.
And I think the other piece of that is the next step. So that was at its fundamental basic is find it, download it, convert it, upload it and print it. At the next level of that is where the learning comes in for students and the learning comes in for anyone, is either A, creating something from scratch, taking a model, manipulating it so that it does fit on a pre-existing.
Or modifying models. There's a lot of customized like parameter. Oh, I'm not going to pull that one out. There's a lot of models out there that have been like built in like SCAD, which is like open source CAD. Like I said, it's a little intimidating. It's a script-based modeling program. You can preview and like get an image of what you're typing out, but it's a lot
of coding.
Transform, it's coding. Right. It's a language, so it's a little intimidating there. But there's a lot of models with parameters that you can just quickly tweak. Last week, I just finished a RoboCode tournament where in my Java class, my students use a piece of software called RoboCode to program behavior into little tanks, and then we battle them. I printed a custom trophy for them and all I had to do was I downloaded the model and then just used OpenSCAD to tweak the text on the model. Could have changed other parameters and things if we wanted to, but it wasn't the goal. But there's a lot of things you don't have to go necessarily from I'm just printing other people's things straight to I've made something from scratch.
Right.
There's an intermediate ground. Yeah. And sometimes you'll get models that like have SketchUp files that you could just open and tweak those. So
I loved one of your students came back and said, for the next trophy, I want to change. So he like, okay,
yeah.
Then you can print the next trophy. Well, give that job to him.
Here's the file.
Yeah. Because he had the trophy. I don't know if he won the trophy. He won the trophy, right?
Yeah, I forgot about that.
Yeah, he came. I happened to be there that day.
So
he came back for the next trophy. I think we should do. And he wanted to manipulate what he was holding or how he was standing or something. And you're like, that's great.
One of the perks of being the winner is you get to redesign the trophy.
That should be part of the class.
Absolutely.
That student actually is exceptionally capable in the world of 3D modeling. That's the kid I mentioned that wants to do like GoPro rails on his Mac.
That makes perfect sense now.
2 years ago, he had done zero modeling.
Wow.
Never had done I think he actually came preloaded with a little JavaScript knowledge, but pertaining to like code or like modeling, that was it.
And that's when you start your inventors club and you start, just coming up with that rail to be able to attach the GoPro to your helmet would be
a great submission to a problem.
Right.
Bank.
Exactly.
That'd be so cool.
I know.
I want to start the problem after school.
Me too. I've got a lot of things to talk to you about.
Well, I'd really like to see like a collaborative thing amongst many schools. Like I think we should have like a South Bay.
Yes.
Yeah.
Absolutely.
Because you've got
a makerspace.
Because there's other schools with things, and everybody needs ideas, right?
Yeah,
absolutely.
And there's no harm in submitting 10 revisions to the same problem.
No,
and I think that'd be really cool. In this area where your high school sits there's 3 or 4 other high schools right in a very close proximity to them where you guys could collaborate. Yeah, totally. And I know that a couple of the other high schools have similar clubs, and
not every high school in the area might probably doesn't have a Form 2.
Right.
So once we get really nice designs, then we could do the final draft print.
Yeah.
Print out really nice pieces.
I'm excited.
So talking about a couple of resources for teachers.
Yes.
Good places to jump off of and get started with. Thingiverse is a great site. It's one of those repositories of different models. Everything that is uploaded to Thingiverse, you can quickly download and print off of your machines. Something that they started probably within the last year, though, is Thingiverse has an educational section now with models associated with lesson plans and content standards and things along those lines. In all honesty, it's a little slim on the depth and breadth of things that they have available. And it's in my opinion, really there's a lot of focus on like realia of things that you can bring into the classroom. But it's a great spot to start. It's a great location to find fun things to print or just anything. You could type in, Samsung Galaxy Note and find different cases that you can print for it. Or you can type in the model of your printer and find all sorts of different modifications and stuff. So Thingiverse is a great place to start. There's a couple of different repositories from museums. I don't personally use this one, but like the British Museum has a lot of their 3D scans online. NASA has a bunch of cool models that they've put on of their rovers and different satellites and things. So there's quite a few different repositories out there. One of Thingiverse, like I mentioned, has a lot of toys and things that you can get kids interested in, just quick little one-off things to print.
That's awesome. I definitely.
Brenda's got ideas.
Got kinds of plans.
Well, I mean, I just personally have learned a lot about 3D printing just since you spent the time with us today. And so I really want to thank you for coming in today and talking to us about what you're doing in the school. And I think it's not widely known of what you guys are doing. And I think probably other schools are not talking about it. And maybe they don't even know that this is such an inexpensive opportunity to put technology in the hands of the kids.
The learning curve is not very steep. It's pretty shallow. The cost is accessible. Like I said, we're not really, we don't have a lot of money to throw around at our school. Right. So it's something that we're, pretty easily to get a couple of different machines. And the materials aren't so bad. Maintenance is really, it's continual, but it's pretty minor.
So they really don't take up a lot of space. A teacher could have one in their classroom, or
they come in different sizes and shapes, but it's definitely bigger than a bread box.
Okay.
Our favorite.
Bigger than a microwave.
Yeah, it's a little like two microwaves stacked on top of each other.
Okay, there you go. That's good.
That's a good one.
Just to kind of get a feel for like how much space, if there is a teacher and a maker space or whatever that.
Yeah, they are desktop. Designed to be on desktops.
Okay. Mm-hmm.
But yeah, some of the cheaper machines are really kind of tiny footprints.
And then again, the cost of these things that you made that attach the pencils, what did you say that these would come out to? Because we're going to have a picture on our website.
You said pennies.
Pennies,
because
pennies.
The filament is so inexpensive.
We're talking... I would have to look at the slice. We could do that real quick. It wouldn't take long. But I would say no more than a couple of pennies. The entire roll of filament is a kilogram, so like 1,000 grams, and it's $17, right? So these probably maybe like a gram tops. I would have to look at some actual.
So
numbers,
less than $1.
Definitely less than $1.
Yeah.
If you throw in pencils, maybe like $2. Yeah.
Couple bucks.
If you don't have the pencils lying around, you're looking at a couple of bucks, but it's all very, very affordable. Your filament really goes a long way.
Yeah.
That's
really
nice.
does.
And you can swap filaments out pretty easily.
Yeah.
Like this is white filament, but they have different colors. And so I want to
full range of colors. I do a lot of drafting in like this like construction orange. But we have a full range of colors. The orange doesn't cost any less than this white. Sometimes it's $1 or $2 difference, and then like I said, you can do exotics. They do some like glow in the dark stuff. Clear is not really an option so much, but they have like a natural. It's kind of a little opaque. Yeah, very cheap unless you start getting into some of the more exotic materials. That can really start ramping up. But I've printed in either a cork or a wood. I don't remember. It was quite a while ago. I'm willing to bet it was wood. And I just remember it smelled like cedar. It turned my whole place. Oh, it smelled wonderful.
Yeah, like you were out in the wilderness.
Yeah. So exotics can be a lot of fun. They can be a little trickier to print with because it's not exactly plastic. It's a mix of plastics and other particulate. Speaking of particular, there's a newer type of printer on the market right now, SLS machines. So back to Formlabs, they also make a machine called a Fuse One, and it's a totally different design of printer. It's using like a powdered nylon essentially, and it's like a tub of nylon powder, and then they have a laser at the top that scans whatever it is, the layer for your model, and then they take a little bit of the powder and they put it on top. They just move it from the bottom to the top, and it buries the print eventually. That's a $10,000 machine. But at last year's ISTE, I wish I could remember the name of the company offhand. I would have to totally go through like a safety and training course for this, but I saw a full-on metal SLS printer, where laser sinestering printer of some sort. But it was 20 grand, which, these machines traditionally are like 50 plus. And I've since seen a couple of desktop models, and this is full on. We're talking about like you can actually produce like workable components, right?
Right.
If SpaceX is printing something for one of their rockets, they're printing it in metal particulate. But just prices are dropping, things are becoming more accessible. I don't think it would be very responsible of me to bring a health safety hazard like that. I don't want my kids breathing that stuff in. But I was talking to the sales rep, and kilo of steel was like $50. So that's
still really reasonable when you think about what you could potentially produce.
The high level of that stuff,
right?
Yeah. I mean, and that's really kind of university level sort of manufacturing and things along those lines, but it's prices are falling. It's very accessible, even for the homeschooled student or just somebody who's interested in 3D printing on their own. It's
the elementary schools. I hear more and more having these 3D printers coming in. And
well, what I'd really like to see is a focus on the creativity and design process. Like yes, these are great. These connectors are fantastic. But it's nothing that a student did, right? It's something to supplement the curriculum. What's really cool is even if it's just as simple as taking a picture and converting it into an SVG file and merging it with another model, that's a start, right? So that's what I'd really like to see more of in education, is students becoming more and more familiar with 3D modeling principles. And
it needs to be like start out as an after-school program and then move towards in an elementary setting, so that by the time they get to you, they've had some exposure.
I am certain that elementary kids could get on Google Images, download something, re-upload it.
I have a test subject for you.
He's
about this big. I think about these schools, and I'm not joking when I say that there's schools that have 3D printers that are sitting not doing anything because no one knows what to do with them.
How to get started.
And I think if there's a parent or a volunteer or someone out there that could be like, okay, we're going to start this after school club. Let's get going under that premise of like actually creating something, introducing the design thinking process, introducing them to how to create something of their own out of Google Images, and then ideating, revamping, and then putting it to.
I mean, for those kids, just off the top of my head, it could be as simple as here's a glass jar. Design a plug.
Design the top. Yeah.
Can't be a cylinder, right? Because it's just gonna slip right through. So figure out how to design that top.
Yeah. My head is spinning with ideas right now.
The next step in there. Okay, now give it a little handle, make it a little easier to make it fit better, make it less material, whatever it might be.
I've got some ideas already in my head about how to.
Absolutely.
Well, thank you again for coming. Did you have any?
No, I just want to know what the best way to get a hold of you. If somebody wants to contact you,
come and see.
Has some questions.
What you've done, what you're doing out here. If they're local in the area,
you can contact me at my work address. That'd be fine. I'm always happy to help folks out.
And what's your work email?
My name is Bryan Adams, so that would be first initial, last name, so BADAMS at BMHS-LA.org. Feel free to reach out. We are more than happy to show people our campus and things that we're doing on campus. Yeah.
That's awesome. We'll have pictures. Yes. We'll have links of everything on our website. So thank you again for coming.
Yes.
A lot of other exciting things on campus going on besides 3D printing.
What?
The robotics.
We've got robotics and VR and all sorts of fun Java programming going on.
That's awesome.
Yeah.
Wow.
We're excited.
Yeah. We got to talk to you again.
Yeah.
Please do.
Well, thank you, Bryan. I really appreciate your time coming up and talking to our listeners today. And this is very informative.
Yeah. Brenda and I have decided we're getting a 3D printer.
Yes.
You've got some room.
Right there. It's going to go right there.
Well, it's my pleasure. And I hope I've maybe got some other people interested in it.
Yes.
Yeah, I think so.
Absolutely.
I think so. I think you've inspired us. So I'm
Yes.
sure you will inspire our listeners. So thank you so much.
All right. And we're out. Hi, everyone.
Hey, I'm Shannon Twaldo.
And I'm Brenda Argano.
And we're your hosts of the MyTech Toolbelt podcast.
And we have some exciting news today for you.
Yeah, we've been selected to be on the Q team for social media champs. So we are the podcast social media champs for Q. So we wanted to just really quickly tell you a little bit about Q. Q is a nonprofit organization that is basically a group of learners who are innovative and community inspiring. They are primarily in California and Nevada. Their membership is free. You can be a member for free. And you can have a premium membership for $40. We'll talk about that on a later episode. But if you haven't heard of Q, check them out. They're great resources on their websites. And we are just one of 4 groups of their social media champs.
Right. So what does this mean to you? Well,
tell us, Brenda.
It means that you are going to also get the inside scoop of what is happening at Q. We're very excited to let you know, and things that are happening around the whole state of California and Nevada.
Resources that are available to you. Also, we will be attending as many events as we can that Q hosts, and we will be reporting on them via our podcast and via Sparks that we will post to the Q website.
Yes, and our podcast is going to stay the same, so don't worry about anything changing. So we just get to keep doing what we're doing. We just get to enhance it a little bit.
Yeah, we're really excited. So reach out to us. Tell us what your thoughts are, anything you want to hear about specifically. We are at obviously mytechtoolbelt.com, as well as all your social media channels, including Instagram.
Awesome. So keep in touch.
Thanks.
Thanks for listening to the MyTech Toolbelt podcast. If you have enjoyed listening, please rate us on Apple Podcasts or send us some feedback on our website, mytechtoolbelt.com. We would love to hear from you. This will help us deliver the content that you want to hear. Thanks, and we're out.